Hey everyone, in this video we're going to be talking about stable, marginally stable, and unstable systems in terms of linear control systems. Just as a quick overview of where we are now in this course, we have looked at different potential inputs to our control systems, these being things like step, ramp, and impulse signals. We've also discussed how to develop models using first principles, and a bit about empirical models. Now, we are ready to talk about the various outputs that we can receive from a control system. In this video, we are just going to go through the three overarching system types that we can encounter, and in the next few videos, we will talk about the physical systems that can cause these various outputs to occur. So, let's begin with what a steady system response is. Well, this is your goal system. By that I mean it is what we are trying to achieve. Remember in an earlier video when I defined a control system as a system that is designed to maintain a given condition, a given output, despite disturbances in a dynamic or changing system. Well, a stable system is just that. We achieve and maintain a steady state output over time. So, a steady system's output is not going to change with time going to infinity. So, when we observe these systems graphically, it is very important to observe how the output fluctuates over time. This will visually show you how your system responds, whether it is stable, unstable, or marginally stable. So, let's just talk about unstable responses and marginally stable responses, and then we'll go through a few examples to ensure that you understand. An unstable system will do the opposite of a stable system. Over time, the system will deviate more and more from your target output. Obviously, this is completely undesired, as it is likely very dangerous depending on the system we are working on. An example of this could be a runaway exothermic reaction in a tank with no cooling system or a broken cooling system. As this reaction begins, the temperature will rise, causing the system to react more quickly, and causing the temperature over time to grow exponentially, like is shown in this graph here. Lastly, let's talk about a marginally stable response. This is a system's output that is fluctuating with time, but is remaining bounded in its output response. So, let's imagine that we had a tank of water here, and we wanted to keep it at 30 degrees. Well, every time our tank temperature drops below 30, we turn on a heater, and every time it's above 30, the heater shuts off, and the evaporation process cools off our water. Well, in this scenario, the system isn't really at steady state, since the output is still fluctuating. But it is not unstable either, as we have a sinusoidal response like this. You could also say that a system's output response is stable if it remains bounded, which means that the output stays within a given interval across all time for a bounded input, like our previous tank example. So, if we applied some finite step to our system, we would know it's unstable if the output shoots to positive or negative infinity, as this proves that the output is not bounded for a bounded input. Alright, so now that we have a basic understanding of these three responses in linear systems, let's look at a few graphical examples to ensure that we recognize the three output responses. I'd recommend taking a minute here and try to identify these 6 systems on your own before we begin to do the solutions together. Let's just say for each of these systems we are applying some input step to them, which just means that we are turning the system on at a defined time 0. Let's begin with example number 1. It is clear that in this system we are quickly reaching steady state. That is, we have an unchanging output as time progresses. Therefore, this system response is steady. Number 2. We have a simple sinusoidal response, which we previously talked about. And since it does not rest at one steady state value, or become unbounded, we call this a marginally stable response. Thirdly, we clearly have an unstable system response as the output shoots towards infinity from a bounded step input signal. Our fourth system reaches steady state and is therefore steady. Number 5 is clearly growing with time and does not appear to be coming to a steady value. This means that the output is unbounded and will continue to grow. This makes it an unstable response. Lastly, we have another oscillating response. However, this time it is clear that the output is becoming more concentrated and steady with time. Therefore, this is a steady system. Thank you for checking out this video, and I hope it helped your understanding of how we can differentiate between stable, unstable, and marginally stable control systems. If you enjoyed, please like, subscribe, and consider checking out our Patreon page to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.